Welcome back to Unit 7, Solving Quadratic Equations. Before we begin, make sure you have paper, your notebook, and something to write with. Okay, let's jump into 7.09, How do we factor difference of perfect squares? You've already learned that the numbers 4, 16, 25, and 100 are perfect squares. Today we are going to look at equations that have perfect squares in them. What is difference of perfect squares? A binomial with subtraction where A and C are perfect squares. Let's look at some examples. In my first example, y equals to 1x squared minus 9. I know this is a binomial because there are two terms. The A term, 1x squared, is a perfect square because 1x times 1x is 1x squared. And my C term, which is 9, is a perfect square because 3 times 3 is 9. In my second example, it's very similar. Y equals to 1x squared minus 16. 1x squared is a perfect square because 1x times 1x is 1x squared. And 16 is a perfect square because 4 times 4 is 16. Now let's learn how to factor difference of perfect squares. How do we factor quadratic equations with perfect squares? Remember, to factor means to go from this form to our parentheses, which is factored form. How do we factor quadratic equations with perfect squares? Remember, to factor means to go from standard form to factored form, so we are creating the parentheses. In our example, we have y equals to x squared minus 9, which is a binomial. Below it is a trinomial, and I see that my b term has a 0 coefficient. And that makes sense because 0 times x is 0. So really, the 0 is just a placeholder. Because I wrote it as a trinomial, I can set up my fill in the blanks. I need two numbers that multiply to negative 9, my C term, and two numbers that add up to 0, which is my B term. Let's take a look at a video of Ms. Franks factoring this quadratic equation. Here, I've written my binomial as a trinomial, y equals to x squared plus 0x minus 9. I'm using a 0 for my b term because 0 times x is 0. Now that I have my trinomial, I can set up my fill in the blanks. Looking at my C term, I need to think of two numbers that multiply to negative 9. And those numbers need to add to 0, my B term. Okay, what multiplies to negative 9 and adds up to 0? Well, I know that opposites, like negative 2 plus 2 or negative 5 plus 5 equals 0. So what if I use negative 3 and 3? Negative 3 times positive 3 is negative 9, and negative 3 plus positive 3 is 0. I got it. Now that I've filled in my blanks, I can write my factored form as y equals to x minus 3 times x plus 3. I notice that inside of my parentheses, I have the same number, 3 and 3, but one of them is negative and one of them is positive. You are going to notice the same thing as you're completing your classwork today. How do we know Ms. Franks factored correctly? Well, if we take our answer in factored form, y equals to x plus 3 times x minus 3, and double distribute, we get x squared minus 3x plus 3x minus 9. Well, negative 3x plus 3x is 0x, 0x is really 0. So my final answer is y equals to x squared minus 9. So I know I factored correctly because my factored form would get me back to my original standard form equation. Now it's your turn. Factor the quadratic equation f of x is equal to x squared minus 144. Step 1, you're going to identify the perfect squares. And step 2, you're going to set up your fill in the blanks. So I want you to think of two numbers that multiply to negative 144, and those same numbers add to 0. Let's take a look at our solution. F of x equals to x squared minus 144. Negative 144 is my perfect square, and 12 times negative 12 is equal to negative 144. 12 plus negative 12 is also equal to 0. My factored form equation is f of x equals to x plus 12 times x minus 12. Now we have a special guest to introduce today's classwork.
Do 7.9 classwork, get full credit on that. Don't forget about it. You know what I'm saying? Don't forget about that. It's the best. Go do that, you want your grade, you want to pass, graduate. Hit my line, you need anything. Catch you later.
Thank you, Yandel, for introducing today's classwork. Use Yandel's message and this meme for inspiration. If you need any assistance, please do not hesitate to reach out to Ms. Franks, Ms. Arlack, or Ms. Wilson.